All right. So, yeah, if something is going down, it's doing this. But then there's a couple ways it could do it. So it could be decreasing at a constant rate. That would be a straight line. It could be decreasing at a decreasing rate, which would be this. See how it's like decreasing really fast and then it's not decreasing so fast? This is decreasing at a decreasing rate. And then it could be doing this. This is decreasing at an increasing rate. Because we go from like kind of decreasing more to like really, really decreasing. It's just so annoying that they use this wording for it. So this is decreasing at an increasing rate. That actually starts increasing, but sure, yeah. I know. Okay. Decreasing at increasing rate. This is decreasing at a constant rate. And then this is decreasing at a decreasing rate. And this is something that honestly I need to draw a picture for to remember, because otherwise increasing, decrease, is the magnitude increasing? Is -4 to -2 increasing, or is that decreasing? It's you know, positive numbers, negative numbers. It becomes a whole mishmash of things. We do it in physics. There's a lot of confusion with if the velocity is to the left but the velocity is going up, is that acceleration or not? And then what's happening with the speed? It's a mess. Okay, so decreasing at an increasing rate is this one. That is when something is concave down. So concave down is when p double prime is going to be also negative. There you go. Okay, if something is increasing at an increasing rate, well, increasing tells me that p prime of t is going to be greater than 0. And then if it's increasing at an increasing rate, again, I could draw a little picture. This is increasing at constant. I'm just going to use some shorthand here. This is going to be increasing at an increasing rate. And then this is going to be... What's up, Equity? And then this is going to be increasing at a decreasing rate. This is AP Pre-Calc? I have even more disdain for this because AP Pre-Calc shouldn't exist. Just go take calculus. Again, this is another example of, like AP Human Geography, they created another AP class so that incoming freshmen or whatever can feel like they're being smart and taking AP classes, and also so College Board can charge for an exam. It's all this classes. AP stands for Advanced Placement.
Yeah, I feel like also, though, in fairness,
yeah,
it is a way that if you were going to take AP Calc, you could take AP Pre-Calc, and then if you at least score high enough on AP Pre-Calc, and then you, like, bomb on the Calc exam, you don't have to go back to
college algebra
when you get to college.
Dude,
that kind of guarantees that you get to start with Calc.
I think everyone in college starts with Calc, though. No,
it depends on your degree. Like, I know a lot of people that started with either trig or pre-calc.
Really? In college?
Yeah.
Oh no.
You're kind of like, yeah, it depends on your degree. Like, a lot of the, like, if you were like electrical engineering or mechanical engineering, you usually started with calculus. But like, if you were most computer science majors, they would start with like pre-calculus or.
That's so crazy, dude. Pre-calc is such like a high school class. Yeah. This is AP Pre-Calculus Beast. I have a question. When it asks you to find whether it's a relative maximum or minimum or neither, would you use a first or second derivative test? I mean, you technically need both. You need the first derivative to be 0. And then you need the second derivative to either be positive or negative, or for whether it's a min or a max. You could also still just use first derivatives, Beast, if you check what's happening before and after the critical point. That's another way to do it. But yeah. But yes, I can help with all these things for all you guys on TikTok that found us. If you ever want to submit a question, which you can do right now, the website for that is www.actualoffice. Yeah, it's on the screen, but I'll say it again, actualofficehours.com. Go there, type your username in, drop a screenshot, hit upload. It'll get put in the queue, and then we'll go through it at some point. So, here's the different increasing, decreasing, whatever things. And then here it says, the elk population changes from decreasing to increasing at this. So that means, so if it's changing, so this is cool actually. This is kind of related to what you're asking about, Beast. If something's changing from decreasing to increasing, right? That means it's doing this to this. That point where something changes from decreasing to increasing, so this would be p prime of t is less than 0. This would be p prime of t is greater than 0. There had to be a moment where p prime of t was equal to 0. And this is called, this all here is called a relative or a local min. So you can find local mins just with the first derivative if you find out where it's 0. And if you check before that point that it's negative, the first derivative is negative, and that after that point the first derivative is positive, then that creates a local min situation. You could also just look for where the first derivative is 0 and if the second derivative is positive. That's another way to do it. So decreasing, increasing, yeah, this implies a couple things here. This implies that p of t is equal to 0, or p prime of t, sorry, is equal to 0, and that p double prime of t is greater than 0. Oh, very cool. Okay. And that's at a different time point. What is super annoying about this is they didn't put this in terms of pi. They put these in terms of decimals, which, man, I would love to just like plug this in. Now I gotta go figure out like how much pi 2.955 is. Like what is that? Is that like 7 pi over 8 or something?
No, it's in terms of pi. It's pi times t.
Okay.
So your t values would be
but why do they put like 2.955?
I don't know. As a physicist,
it's such a weird number. Why would you use that?
When it's convenient, I would just call that 3. 3 and 5.
Oh, I see. Okay.
That's just me.
Okay. Because then this will become 3 pi over 4, which I'm cool with. I guess because...
I guess equity says use Desmos. I guess it's a calc problem.
Oh, do you get to use that's another thing, which, wait, what? That completely changes this. If I'm allowed to use Desmos for this question, I wouldn't do any of this shit. What I wanted to do is, I also, like, that's hilarious. They're using like 420 as the amplitude. Someone's got a sense of humor here. I would figure out what p prime of t is and what p double prime of t is, and then I would just check what happens here. So, but okay, if I get to just use Desmos, really? Equity, is that confirmed? You get to use Desmos on AP Pre-Calc. How does that work? Wait, it's a paper test, no? I'm confused.
Maybe they might let him use like a TI-84 or something like that.
Okay. Well, I'm cool with the TI-84. Yeah, that's a legit thing to use. I'm cool with that.
What?
It's a hybrid exam?
Hybrid?
The
Yes,
fuck
that
does
makes
that mean?
sense. Now even like the SATs you get fucking Desmos on that.
You can use Desmos for your AP. Dude, how does that work? Do y'all get a laptop to sit down at? Man, I was born in a weird era compared to you guys, I guess. Or you guys are born in a weird era. Okay. So, I guess, well, I'm too lazy to, like, OCR this, so I'm just gonna tell chat to OCR it for me. It's already there in the software? Oh, okay. Okay, cool. So, whatever. If I get to go to Desmos, love, I'm just gonna do this. I'm gonna do y equals, and then we have to make sure this is actually pi. Pi times t And then I think you put like a capital T to make it a slider. Wait, how do I get it to be a slider?
I just use X since
X?
T's our only variable. So
Okay. Okay, and then you really gotta like, so 420 plus 1250. So this already tells you that our window is way out of whack. Our y-axis needs to start at probably like 800. It needs to max out at 1670, so 1700. There we go. And then x, here we'll go from 0 to, what do they want? Where is it from? 0 to like 5-ish, or up to 9. Cool. MCQ is online and FRQ is on the test booklet, but the questions are online. Okay, interesting. Okay. So, all right, interesting. So if I get this, I think what I want, and this is sine, yeah? I want the midline for this too, actually. So I'm going to plot y equals 1250. Because this will tell me when things go from being concave up to concave down. Okay. All right, so let's go through all the things they wanted. The minimum number of herd of elk occurs between 4 and 5. Well, that's not true. Yeah, so between 4 and 5, it's chilling. It's a medium amount of elk. So this one's not right. Okay. Decreasing at an increasing rate. So let's remember that decreasing at an increasing rate looks like this. What's up, Mathan? My favorite streamer. So 2.9, so between 3 and 5, where's that? So between 3 and 5. Interesting. Yeah. Do you see here? Here is the 4.955. Wow. Oh, this is cool. I can just have it mark the points, right? Let's have it do that. Yeah. And then I'll just take the screenshot so I can show you guys where this stuff is. Will it not plot the min for me though? Man. Oh, you know what I can do? I can get what the min would be though, right?
I think if you
830. I tried clicking on it. It didn't do it for me. But this will work,
yeah,
right?
Normally it normally it pops up in the line.
There we go. There. Where things intersect, it definitely does it. So here, I can do that. I can do that. I can do that. I can do that. These are all great things to have. All right, and then I'm going to just grab this screenshot so we can see it. And so equity, the reason why I know that this top and this bottom happens because if the amplitude is 420, then it's going to oscillate 420 up and 420 down from the midline, which is at y equals 1250. So that's why I did 1670 and 830. Okay, so let's just take this graph. Great. Okay, so decreasing at an increasing rate, I think that part is true because that's this. So from here to here, you are going down and you're doing so in a concave down way, which I guess, wait, for pre-calc, I don't think they know about concavity. So, but you can see that it's going from kind of decreasing to really decreasing a lot. And then it goes back to not decreasing so much. And then it goes to increasing. So this is also called like an inflection point. Is the name for this? It's an inflection point. So this one's true. Increasing at an increasing rate between 6.9 and 8.95. Well, that's also true. Can multiple things be true? Equity? I think these are both true.
I believe so.
Yeah, I believe so,
says
right?
which of the following statements
Which of the following
is true, so I'd assume so.
Yeah. And so, yeah, that's happening from here to here as well. Because, again, increasing at kind of a slow rate, increasing really quickly. This is the fastest it will increase before it starts quote-unquote slowing down again next. What's the hardest topic in AP Calculus BC? Sequences and series. It's always the thing that trips students up the most is sequences and series. The elk population changes from decreasing to increasing at 4.95. That's also false. It is still decreasing here. It is still decreasing here. The rate at which it's decreasing is changing from increasing to decreasing. That is true. But, yeah, this one's false. Sensation. What are these photos, dude? I love the total tubular, man. That one's great too. Okay. So yeah, does that make sense, Equity? Why it's choice B and choice C? Do we explain it adequately? That actually starts increasing, yeah. Cool. All right, you're welcome, dude. It's funny, I thought this would be actually a quick question, but it was, in fact, kind of a longer question to go through because we had to check all of them. It would have been even longer if I didn't have graphing. Thank God for the graphing. Equity. Alright, nice. Okay, let's post that.
Which question was that? Equities.
Oh, wait. Why did I posted breasticles accidentally. Damn it. Ugh, this is what happens with the me first. I forget that if someone has claimed me first, it doesn't. Okay, I need to. All right, let me write that down. I need to, for my own sense of things, I need somehow for me first to trigger the queue. I'm sorry, breasticles. I messed up.
It's okay.
Okay.
There is a slight problem with that.
What's up?
If 10 people use
No, there's a
something
cooldown
similar.
on it. There's a cooldown on it. I think you can only trigger me first like once every 30 minutes. Or I think it's limited to once per stream, or maybe twice per stream. I do have a limit on it. Okay.
Use this as a hawking stream. Like, do you want to buy a NES?
What's the hawking stream, dude? What?
Have you not noticed? I've got like 4 NESs and 3 SNESs behind me.
I do see that is a lot of old. Did you see? Apparently, GameStop has this thing with it's called because they have so many people trading in old things. They now have GameStop Retro in the U.S. where you can buy retro games at GameStop everywhere in the U.S. Apparently, it used to be only like a select thing. But
I just know because the Best Buy girl's back and she's doing the advertisements.
CEX sort of does that, but there's so many independent retro shops. It's like mental. There's like 3 per city.
Yeah, so for us, like, no. Oh, Equity has a 2. God damn it, Equity. This is your other question? Sorry, I just marked your other one in. I'm a mess today.
Oh, no.
Okay. I'm really fucking up today. Sorry. I saw Equity as question number 6. I didn't realize this was number 2. Okay, and then I just deleted it. Oh, okay. Here, I'm just manually putting this in for you. Equity. Okay. Equity. Let me grab this. Okay. Post. Post, please. Okay. I totally screwed up the queue today.
Oh, no.
This is what I get for having a weekend. Let me see. What was I going to do, though? Let me help out Jay with one. Just because, Jay, you asked a bunch of questions last time. I never helped you. And then I'll go back to, I need to get to breasticles, which I deleted, and then equities I accidentally deleted too. Yeah, let me just do one of yours, Jay, just to, because I know you asked a lot yesterday, and you actually need help. All right, we'll try this one. Okay, and then this one I'm doing of yours so that I know not to like screw this up next time and delete another person's question accidentally. That is the one you submitted at 5:33, so that is this one, question 3. Okay. I can put check marks on things. Maybe that'll help. Okay. All right. Calculating acceleration direction. 2 tugboats are pulling a 4.2 times 10 to the 3 kilogram barge into a harbor. The first tugboat exerts a force of that many newtons. The second exerts it of that many newtons with, I hate this convention, east 37 degrees north. Because you would think it means 37 degrees east of north, but really what it means is 37 degrees north of east. I don't know why they do this. Whoever came up with this is, I guess it's a relic of the olden days.
It's a maritime convention.
It's a maritime convention. It makes no sense to me, right? This should be east, so 37 degrees east of north, but it's not. It's 37 degrees north of east. Anyways.
I think it's got something to do with relative.
Maybe.
Location. Fuck, I can't remember.
Yeah. Well, at least we have a diagram, so. Okay, the second tugboat exerts that force. Calculate the acceleration of the barge. Great. If you form a parallelogram, the resultant force is the longest distance inside the parallelogram. That is true. That's because it's the hypotenuse of a triangle. Okay. So when you have this question, yeah, it's not just Canadian physics. It's, yeah, as much as I would love to blame things on just being from Canada, it's just how things go with physics in this. It's a maritime thing. You want to break these into components, Jay. So instead of having this force F1, which points in a random diagonal direction, you want to create 2 different component forces for it. So this right here is going to be F1x. And this is going to be equal to F1 cosine of 37 degrees. And then this one right here is going to be called F1y. And this is going to be equal to F1 sine of 37 degrees. Cool. And then we're going to go convert this one over here to component forces. It has like an up-down and it has a left-rightness to it. Yeah, like that. I don't know, I can't really draw things today. Okay. This, we're going to have F2y, which is going to be equal to F2 sine of 12 degrees. But then the key thing here, Jay, is that this needs to be negative. Like, don't mess that up. Because this is pointing down, sometimes students will forget that this needs to be negative. This, however, will still be positive, and this will be F2y is equal to F2 cosine of 12 degrees. So then, in order to find the acceleration... Did I fuck up? Yes. Yes, thank you. Thank you, Prescos. Yes, this is F2x. This problem must be the first sign of madness. What's up, Zach? Love the puns. Shout out to Zach. I feel like I'm going through some signs of madness today. Yes, that's at the adjacent side. Yeah, not the hypotenuse. Yeah, sorry. I can't like get to it. It's whatever. It's hop like this. There you go. It's over here. It's this one. Correct. Yes. Okay, so then to get acceleration, sum of forces is equal to mass times acceleration. So we need to add the components back up. So we could say F3 is equal to F1 plus F2. Let's make that like the resultant force. So then F3x is going to equal F1x plus F2x. then f3y is going to equal f1y plus f2y. So all that's left is we got to go calculate some numbers, which this is annoying. But sure. What is f1? 1.8 times 10 to the 3. Okay. So 1.8 times 10 to the 3. And then let's make sure we're in degree mode. Yep, good. So I'm going to do that times the cosine of 37 degrees. That's f1x. And then plus f2x, which is going to be 1.3 e to the 3. Howdy, celebrity comedy. What's going on, dude? Times the cosine of 12. Great. There we go. And so we get a number there. 2709 newtons. And then if we want to do the y component, all you do is you just change all these cosines to sines, and then we have to make sure one of them is negative. So this is now sine. This is sine as well. But then remember that the F2 one was a minus. So we put a minus here. And that gets us around 813. Okay. So now you can draw what your resultant F3 force is. So that's going to be kind of something like this. Where F3x was equal to 2709. And then F3y is equal to 813. But we want to know this. We want to know the total force, not just from the components. Because we eventually need the total acceleration, and then we also need the direction. So you get this by doing the Pythagorean theorem. So I'm going to say that F3 is equal to the square root of F3x squared plus F3y squared. We can get some calculations for that. So I'm going to do this. Yeah, I know how to do, yeah, for sure. Translations, yeah, those are not too bad. Celebrity comment, if you want to submit a screenshot of a question like that, we can do it on the stream. There's a website you should see, the actualofficehours.com. There you go. Sensation has it as well. Discord. I think exclamation point submit should work as well, Sensation. There we go. Thank you. Okay.
Way ahead of you.
I know. Yeah, there's latency, I guess, on my side. Okay, there we go. All right. So 28.5. Okay, so F3 is equal to 28.5 newtons. And then if we want to get the direction for that, then I want to figure out what this angle is, theta. And someone asked me the other day what was my favorite trig function. I told them I think it's arctangent, because this is how you always can quickly find the angle. Is if you do the arctangent, and remember tangent's opposite of adjacent, that's going to be the arctangent of 813 over 2709. That'll get you what this angle is right here. All of them. Don't worry, I'm paying attention.
I am paying attention.
I appreciate that. Yeah.
That's why I've got so many fucking screens.
Yeah. Someone was trying to compete with me. I was out the other night or something, and someone was a stock trader of sorts, and they said, "Oh, I have 4 screens." I was like, "Bro, I got 6." And I don't even trade stocks.
I've just got one for the TV and one for Discord, and one. I've got a few too many, to be honest. But
it's got a few too many. Yeah, it generates heat. Okay, so this tells me that theta. So once we do this, once we do the arctangent of those two, Jay, we're gonna get 16.7 degrees. I will always just say that whatever these numbers are positive. Whatever these numbers are, I'll just make them positive, and then I'll look at the diagram to know whether that's going to be north, east, south, or whatever. So, for instance, this could have been like a negative 813 if it was pointing down this way. But I would still just put positive numbers in here and know that the angle I was finding is this one. And then I know it's whatever, that many degrees south of east. But this is up, which means it's going to be north of east. So I believe the way we write this is east 16.7 degrees north. I think this is the correct maritime way to write this.
It just occurs to me, isn't that how you write ascensions as well?
Ooh, what's ascensions? What do you mean by that?
When you scan the skies for radio signals, you say, I found a signal and it belongs to, and don't you group it in exactly the same way?
I didn't know. I haven't done that. Ascensions in radio?
Somebody, it's, you give it a coordinal direction and then so many seconds, isn't it?
Oh, okay, yeah.
And another coordinal direction.
Yeah.
Because from a human perspective, it's a flat plane, and you're looking up. And so you say, it's so many things north, 13 seconds east. Because then that doesn't help in 3 dimensions. Azimuth,
Jeff says, maybe? Azimuth? Yeah.
The only experience I've got with that is the film Contact.
Oh, Contact, that's a great film, yeah. Old one too, man. That's like a 90s film, no?
97?
Yeah. Makes sense. Okay, but then, the other key thing here is they didn't actually technically want F3. They wanted the acceleration. And so what we have to remember is F is equal to ma. So if I want the acceleration, I have to divide that F3 by the mass. Right ascension. Right ascension is what Eclipse is saying.
Yeah, because she was screaming it down the walkie-talkie in the movie, but it's been a long time since I've seen the movies.
Who's that? Who's the female protagonist in that one?
Jodie Foster.
Jodie Foster, that's right. Yeah. And
I didn't find out until later, until after, that it was written by Carl Sagan.
Oh, really? It was written by Carl Sagan?
Contact with the book was written by Carl Sagan.
Oh, the book. Oh, okay, but not the screen. Carl Sagan died in the 80s, I think, right? Or the 90s?
No, I can't remember. But it was anyway. It was a big thing. It was Carl Sagan. I didn't know it was. But then I didn't know who Carl Sagan was for a long time.
Wait, didn't I just tell you though who Carl Sagan was because of the pie in the universe quote, right? We were just talking about Carl Sagan.
Yeah, I just mean I didn't know who he was until they did a new series of fucking hell, I forgot what it's called now.
Cosmos, yeah, which used to be Neil deGrasse Tyson, I think. Is it not
still? But yeah.
Is it still him?
Anyway, I didn't know who Carl Sagan was until I found out about him, and then
yeah,
because he wasn't particularly popular over here. Historically, it tended to be our
the original was Sagan. Oh, okay, cool.
Yeah.
Okay, so Jake, this is going to be your magnitude of acceleration. We just took whatever F3 was, we divided it by the mass, and then this is going to be the direction for the acceleration, because the direction of the acceleration is the same direction as the force. Right, there you go. Magnitude direction assumes no friction. And so no, he said ascension, I think. There you go. Those are two answers.
Of the many things I've just said, I don't remember.
I've said many things. Okay, Jay, does that help you out with figuring out magnitude and direction? Yes? Great. Good job, Jay.
Assuming no friction on a barge in water is absolutely like diabolical.
Yeah, there's definitely a lot of friction on that.
I feel like that's one of the major times when you would definitely not want to assume no friction.
See, I would argue that there's less friction, but more water pressure.
Water pressure? What water pressure
the pressure of the water acting on the barge would increase the normal force, causing more friction.
Correct.
Yes.
Yes. There's fluid friction.
That's quite confusing, actually. Yeah.
Buoyancy. Okay. Nice job, Jeff. Or not Jeff, sorry. Jay. My other J friend. Your question will show up here, and then here we'll post the screenshot for you. That's what we did. But that's a pretty standard physics question. It's a little monotonous going through it, but it's a good skill. Once you've done it a couple times, it's just like clockwork. But there you go. Also, you get a bond coin for asking a question.
I think I've seen those questions in GCSE physics before. Possibly.
I'm sure you have.
mathematics as
It's a pretty standard question to ask. Yeah, just add two forces and figure out what the resultant is.
well. Yeah, so definitely crack on with that one because you'll need to know for later.
Yeah, it feels like particle motion, where you break down the particle. Yeah, exactly. Yeah, a lot of physics is breaking things into components in just X or just Y, and then doing math with them there, and then putting them back. Yeah.
Russian components, American components, all made in Taiwan.
Disqualified.
I love that movie.
All right, let's see. Let me spin the wheel once just to see, and then we'll do breasticles because I accidentally deleted his. But let me at least spin the wheel. I haven't spun the wheel today. What was this? Omari? This is another. Oh, very interesting. Look at all these fun ones we have. Okay. Let's go choose a winner and see who we're gonna go help out. I haven't spun the wheel yet today.
Let's go gambling.
Gladiator.
That's dope.
Ooh. This is fun. I remember Gladiator, I think, is the one that asked us the question. Was it on Thursday? When we did this? I really enjoyed this.
Yeah.
This was fun. I thought I was gonna hate this. It was actually kind of cool. Yeah, okay. The diagram shows a regular octagon. Write a single vector that is equivalent to each of the vector expressions. Oh, interesting. Okay. Well, if it's an octagon, I know it breaks things up into 8. Right? Octo 8. Yeah, good. So are all the interior angles 40 or not the interior? What's the name there's a name for this angle. I think it's 45. I think it is 45 degrees though. I think this is called the exterior angle. But I'm pretty sure this right here is 45 degrees.
Wait, what's all the interior angles of a polygon?
So, yeah, so the sum of the interior angles is equal to n minus 2 times 180.
That's it.
That's equal to the sum of the interior angles. And then the sum of the exterior angles is always equal to 360, I believe. Because you have to go around in a circle. So then an exterior angle is just equal to 360 divided by n. Which that makes sense because 360 divided by 8 would get you 45. Okay. So there we go. So I know that's what the exterior angle is. Okay, so all these things are nice perfect diagonals. Okay, so HA plus AB. Oh, that's so funny. And they want to know what this is. Well, wait a minute. Am I allowed to just write that this is equal to HB? What do they want it
I'd
written as?
imagine so.
Right? I thought this was gonna be more fun though.
I mean, that's how I would. I think it does in B and D. It looks like it gets more
A little tricky.
interesting. Yeah.
Okay. All right. Let's see. GH minus FG. Okay. So if you do GH, oh, let's not delete that. So if we do GH, oh, wrong color. And then minus FG. So FG was going this way, but now I need it to do minus, so it's going to go that way. So then that's this. Oh, I see. Yeah, wait, where the hell is that? What? Where does that go? GH minus FG.
Reads like 0 to me.
Well, it wouldn't be 0. So let's assume everything has like a side length of 1, right? Then this minus FG also has a side length of 1, but it has components. And because this is a 45-degree angle, that means this is square root of 2 over 2, and this is square root of 2 over 2. So this will go up, but then it'll come down and diagonally. But the amount it comes down will be only square root of 2 over 2. And the amount it goes to the right will be square root of 2 over 2. So I think we have to write this. I don't think that corresponds to anything here. It doesn't correspond to like just a point. So it's ED? Is it? Wait, Jeff, why are you saying it's ED? ED is square root of 2 over 2. I agree with that. But then this is square root of 2 over 2 up. This is going to be 1 minus square root of 2 over 2, right, Jeff? Yeah. Okay. I think actually they want numbers. Well, wait. What? How can I get numbers though? Write a single vector that write a single vector is equivalent. How, what the fuck do you do here? How?
I'd assume in some way, shape, or form it wants us to break it into components.
Yeah, right? But I don't have numbers for anything.
We can't. And that's what makes it kind of weird. Because on one hand, I want to just be like, it's the x component and the y component. Just write one vector that's like, gh sub x minus fg sub x, and write it as one vector. But I don't know if that's what they necessarily want.
Yeah, okay, so maybe we'll put a question mark on this. This one, I already know, right? So FE plus BA, that's going to be equal to 0. Because you're going to the right, you're going straight to the left, cool. GA, so they're saying here, let's just see if the other ones kind of make sense. GA minus EH. So EH was this, but now I'm going that way. Plus DG. So plus, dude, this is so wacky. Whoa, what the hell? Do we rewrite it GF and add?
No, I think I see, at least for the last one.
Yeah, what do you see?
If you moved that,
GA, and then minus EH is this way.
Other way it should be, right? Going from H.
Oh, minus E. No, right. Sorry. So EH would be that way, but minus EH is going the other way. Yeah, okay, I got you.
And then you got your.
And then you got plus DG, which is that way.
And then if you move that EH vector up to A, so that it's going A to D.
Oh, bingo.
Triangle.
Yeah. Well, then it's just 0, right? It's also 0.
Yeah.
That's actually pretty cool.
And then.
Yeah, because look, this to this.
ChatGPT says that there's no labeled single vector for B.
Okay, so this one does not exist.
I guess.
Oh,
I guess
no.
check this out.
Yeah. Yeah. Okay. Cool.
I don't know any way to.
Yeah, I don't really know any way to see it either.
Yeah, I mean.
Unless, again, you started calling this side length n and then started breaking it up into square root of 2 over 2 times n and whatnot. You could do that. I think I see it. GH is equal to CD minus. Wait. Okay, here. Let's get rid of all this. 1 sec. Okay. GH is this. But you're saying GH is equal to CD. Okay, I'm cool with that. Sure. Minus FG is equal to GF. Minus FG is equal to GF. Okay. So CD plus BC is equal to, wait, BD. Wait, I don't know. What? CD plus BC is not equal to BD. BD would be this. Oh, CD is the other way. Sorry. I wrote CD wrong. Sorry. There we go. Wait. Okay, first of all, GH, Jeff, is equal to minus CD.
Yeah, that's what he said.
Oh, did he?
Yeah.
GH. You corrected yourself? Okay, sorry. I didn't see it. Okay, sorry. Let me think of this again. Yeah. Minus FG is the same thing as GF. So we have GH plus GF. Oh, I see. And so then it's just oh, this is too funny. So GH plus GF is the same. Wait, GH plus GF is the same as FH? We're saying?
I don't think that's correct.
That's not right. No.
Disqualified.
I do agree. Like, okay, so going from G to H and going from G to F, that still should get you here. I don't know where this is. If it was this, if it was GH plus HF, then I think you could say GF.
Yeah, it's just
You can
because the
cancel
problem
these
is that
out.
with the direction, it just doesn't work like that. I think chat's trying to like make
Do some
sort of,
transitivity
like,
stuff.
Yeah, but
Yeah, chat's having a bad time with spatial recognition right now. It sees the math, but yeah, no, I see what chat says, and ChatGPT is, yeah, again, not always correct, especially when it has to do with like visual stuff. It's kind of difficult. It's great with manipulation of just like letters and stuff, but
well, and I think that's what it did there. Is a lot of the time with the vectors, if like with the H to A and then A to B, we can just say H to B,
yeah,
assuming that the tip ends at the tail, but in this case it doesn't.
right.
Right.
Yeah. Yeah, H to A and then A to B. You can cross these out, and then that's the same thing as H to B. That's just like the I guess what is it, like transitive property of vectors or something, if that's a thing.
Something like that.
Something like that. But yeah, if you're doing this is G to H plus G to F. But you need the middle two things to match up. So I don't know. I think they kind of messed up on this one.
Yeah, I just don't think there is one. I don't see any way that, like, at least without numbers or breaking it into component forms and adding numbers, that we could.
Jeff says
like an equivalent vector.
GH is the same thing as minus HG. So could you then say that this is then minus HF? That just doesn't seem right.
I don't think you could, because even then we're just kind of manipulating like how we look at how we move through the vectors, but it inevitably doesn't change the underlying problem that without, like a preserving angle and magnitude, I don't see any way that we could possibly rearrange these vectors to conveniently work out without
Yeah.
rewriting it in component terms.
GA. I want to see how the other one works. GA. EH. Okay, EH. So we had to do it that way. So, okay. How this worked, just to try to think about this. We know that minus EH is the same thing as plus HE, and HE is the same thing as AD. So that's why this became GA plus AD plus DG. Now these are all transitive, right? A to A, D to D, but G to G, GG is just 0. I don't think you can do it when there are minus signs in front of things, though. I think that's the crux of this.
Yeah, it looks like the only way that I can find to get that would be with component forms. If we were to say like the length is n, you could do component forms of it, but past that, I don't know. There's not really any way to do it.
So Gladiator, I think your book made a mistake, which is okay.
Yeah, unless they want you to either say that there's not a simple way to do it, or that they want you to break it into components.
Yeah. I think everything has to be positive in order to do this cute little transitive property thing. I think because when we say like AB plus BC is the same thing as AC, it's because this is the start and this is the finish, and then this is the start and then this is the finish. So if the finish and the start here are the same, you can kind of just get rid of them, and then now it's just A is start, C is finish. If there's a negative in front of it, now you're starting your finish flip.
Well, and I think technically you kind of can, as long as you're not like opposing directions. It's just that by adding a negative, we're rotating that vector, and then that it doesn't work out as easily. Like if for minus FG, if there was like a point P that was at wherever that ends up, we could use that like sort of like transitivity to be like, yo, it goes from G to P, but since we don't have that, there's
got you. If if we had this here
to do that.
Which country is that? I'm from Canada. Gladiator, are you from Canada? I forget. There are a lot of Canadian people on my server. Kaiju edits. 88296. Yeah, Gladiator is from Canada. Kaiju, is this a question that you have seen in your Canadian school of things?
That's kind of funny. Do you know what edits actually means in the original word?
Edits? What do you mean edits?
The word edits, do you know what it means in its original Latin?
Changes? What does that
edit?
mean?
No, to eat.
Ah. I like to eat.
The phrase canis canem edit means dog eat dog.
Ah. Edit.
So when it says kaiju edits, it says big monster eats.
Big monster eats. Oh, you mean? Okay. I see what you're saying. Oh, you're saying in Japanese, edits means to eat.
Kaiju means large monster. Edits is Latin for to eat.
Oh, okay. Kaiju, that's your origin story apparently. Okay, cool. All right, good question, Gladiator. I think there was a mistake on number 2, but it's okay. It happens.
See, I have a plan.
Okay, I did that correctly.
Who's next?
I was gonna do Brascals. Brascals, teach me. What are we doing? Let me find out what your question was.
I'm going to teach you where the D'Alembert solution comes from.
D'Alembert. Okay, here we go. Derive the D'Alembert solution to the wave equation. Kaiju says, I'm not sure. I'm retaking my senior year, so I'm dealing with Calc 1 and Math 31. Okay. All good, Kaiju. Well, Kaiju, if you ever need help with similar stuff like this, you can always go to our website. It's www.actualofficehours.com. And this is where people are putting their screenshots in for homework questions that don't make sense. Then we go over them here on the stream. Of course, if you ever want to figure out when we're streaming, there's a button here for the streaming schedule. And so this has a calendar of all the things that are happening. Oh, nice. Justin's on the calendar now. Love that. Okay, so we'll go raid Justin after this. But yeah, Justin is now on the calendar. And then yes, tomorrow we won't have a stream because I have to do an AP Physics 1 review. But if you're taking AP Physics, or if you just want to hang out and learn about AP Physics, that'll be tomorrow's stream. I'll add an additional one on Wednesday to make up for us not having the Tuesday one. Yeah, Justin. Oh, Justin, let me know what. Send me a hex code for what color you want. Eric is like this nice little baby blue. Zach is kind of like a mauve. What do we call this? Like a mauve? It's in between like blue and purple. And then
I feel like it's closer to purple. Like when I look for it, I look for like what seems like a purple.
It seems kind of like a purple.
Blue
Indigo?
maybe.
Indigo maybe? Yeah. And then Penn Center is red. And then I think Math Pond is green. Yeah, Math Pond is green. So I say, if you guys want, or, well, please, the default is gray if we don't have a color for you. But yeah, let me know what color you want, Justin, and it shall be yours. Roy G. Biv says it's indigo. Okay, one sec. TikTok doesn't think I'm being active. Oh, you're Milkman 145 in the queue. I just thought we had to use... Oh, no, you don't have to use... No preference? Justin, you have to tell me something, though.
Emotional, damn it!
This is like when you ask a girl, like, where do you want to go to dinner? She says, I don't know. Just pick somewhere. It's like, no.
Oh no.
I know that. That's a mistake.
I saw a list of things today. It was like, places not to take women on dates, or first dates. And it was just really obvious, not really obvious stuff in the way that you wouldn't take them. It was really obvious in that's where you fucking would take people on a first date. It was Olive Garden and, McDonald's or whatever the fuck it was.
Mackie D's.
It's like, you don't know these people. You know fuck all about these people. It's like, you're going to take them somewhere cheap on a first date.
Oh, I broke that rule. The girl I took out on Friday, I took to a very expensive place.
No, don't do that. No, A, expect it, and B, you might just
I wanted to go.
You wasted loads of money.
Well, also, otherwise, I really wanted to check the place out because it was the restaurant was owned by a very famous music producer. I use his plugins all the time in my stuff. And I can't go to that place by myself. It's just like lame. So it's kind of like an excuse. She did try to pay. To be honest, she did try to pull her wallet out. So she did try to pay for it. So, or pay 50-50. But I was like, I don't do that.
Oh shit, not good.
See,
I'm inviting you out to dinner. I pay for it.
Is I choose somewhere where I have a gift card. So like one time I matched with this chick on Hinge, and this dude, I had given him a Zeus work at Take 5 with oil, and I had topped off his oil for free out of policy.
Nice. Good for you.
I had poured a little extra in, and he was like, yo, man, I appreciate it. Gives me a $25 gift card. Well, my cheap ass isn't about to actually, try to pay at a restaurant. So I asked her, I'm like, yo, do you have a preference? She's like, no, anything works. And I was like, and it was one of the, multiple,
oh, it works for a bunch of different restaurants?
Garden or Outback or whatever.
Yeah,
I was like, well, does this one work? She's like, yeah, that works great. And I was like, fuck yeah.
Beautiful. Nice.
Good job.
Okay. Someone, you guys saying 0000? No, I can't have his hex code be just. Is that white or black? I think it's black. Or
it's white.
It's white. Yeah, I forget which one is.
I have to think about that for a second.
I think black is the absence of color, though, right? So wouldn't 000000 be black? It is black. Wait. No, it is black. It is black. Yeah. Because
the fuck is F then?
F is 16. So F is. I think all F's is white because when you have all the colors together, that's white. When you have the absence of color, it's black. I'm pretty sure. Okay.
thought it was. Black is 0, white is F.
There we go.
Yeah, triple F is white.
All right, we figured it out. Okay, there we go. RGB, yes. Okay, here, let's do this so we can help some other people out. All right, derive the D'Alembert solution to the wave equation. I think the wave equation is this. Is equal to, I don't know, something, and then it's like, oh wait, no, it can't be this. It's this. Is this the wave equation?
Yeah, if you want to be, well, minus there's a c squared on the x term. And that notation is like really convenient in physics when like pi is your wave function, but normally we just use u.
Okay, we can use u. That's cool.
Use u,
and then,
right?
And then there's just a c squared here. That's it. Is there a minus c squared?
No. C squared is just your wave speed.
Okay.
In this case, that's actually part of why we like to use c squared, at least for various reasons. But like notation wise, it's c squared implies that it's positive.
Okay. Cool. All right. Where do we go from this?
So we're also going to have our initial conditions as u of x comma 0 being equal to f of x.
Okay.
And ut of x comma 0 is going to be equal to g of x.
ut. Oh, so dudt.
Yeah. So
yeah. Okay. I got you. Dudt of x comma 0 is equal to, sorry, what?
G of x.
G of x. Okay.
And those will be our initial.
So this is our initial time, and then this is like our initial velocity per se.
Yeah, exactly.
Okay.
All right. So what we're first going to do is we're going to want to move the c squared uxx term over to the left-hand side. Yep.
And I think I'm going to use this shorthand. I'm going to say utt minus c squared uxx is equal to 0.
It's a lot faster.
Yeah.
So now what we can do is we can factor out our operator. So you're going to get dtt minus c squared dxx.
Factor out the operator. Oh, I see, because it's all acting on you. Mm-hmm. Zach says the curse notation. You don't like this notation, Zach? Zach's not a fan of it, apparently. Okay, but we're gonna factor out.
I mean, it's fair, but it's like 30 times faster. But
okay.
Do that.
And oh wait, sorry. This is gonna be c squared, and this is gonna be c squared dxx, right?
Mm-hmm. Yeah, and technically, d is a partial in this case.
Okay. So wait, do I write that like this?
Yeah.
Okay, and then this is gonna be acting on u.
Mm-hmm.
I hate this notation. He hates this notation. For those that want to get why, okay, so this right here is the same thing as this. This just means take the derivative with respect to t and then take it with respect to t again. Yeah. Okay. Now
what we factor our operator again. The operator works a lot like a polynomial in this case.
Oh, no way. Am I gonna do this? Really? Is this valid? Is this what you want me to do?
Almost. Imagine our del tt minus c squared del xx. Imagine that was just like a difference of perfect squares.
Yeah.
We could just factor it.
Right. If this was a minus b, or a squared minus b squared, this would be a plus b, a minus b.
Mm-hmm.
So I guess if I have a minus b, I can also write that as the square root of a plus the square root of b times the square root of a minus the square root of b.
Yeah, I guess you could do that, but we can just do that with the first a squared minus b squared. And just write it as del t.
Oh, sorry.
C del x.
So whoa. Okay, so sorry. I think okay. You're saying that the act of doing the derivative twice is like an exponent. I guess we do write it that way.
We're treating it a lot like an exponent in this case.
Oh, this is wacky.
Factoring in it.
Oh, okay.
Works out.
Sure. All right, fine. Okay, so that's going to be del t This is probably why Zach really hates this notation. Because now it's like, wait, why did we just get rid of one of the... I get it. And this is going to be C del X. And then this is going to be del T plus C del X.
Oh, Zach makes it. He says it's because it's hard to tell what U is a function of in this case.
Be careful with this, though, because this is a linear operator. Nonlinear operators don't follow this rule. As someone who has had to solve nonlinear PDEs, this is an important distinction. Warning.
It is, in fact, important.
Okay. But I guess we're okay, because we say this is linear?
Yeah, it's a linear operator. We're just doing the Delaware solution of it, but it's linear. We don't really have to worry about it in this case.
Okay.
In other cases, we would, but in this case, it
cool.
does work like that. What's cool is these are actually two transport operators. So like our transport equation would be the second operator that we wrote, and if we had a negative for the speed, it would be the left-hand side, but that's
okay.
Just kind of a tangent. But so now we're going to introduce our characteristic variables, and you're not going to like this, but we got to use Xi again.
No. I hate squiggle, dude. Fucking squiggle. One of these days, I'm going to learn how to draw squiggle.
Yeah, it's unfortunate how much it gets used, but
okay.
It gets used a lot, sadly.
Okay,
so we're going to say that squiggle is x minus ct.
X minus ct. Okay.
Mm-hmm. And then we're going to have another variable. I want to say it's called nu, like nu.
This one?
It looks like an n, yeah. And that's going to be x plus ct.
Okay.
All right, and then we can take our derivatives. So partial xi by partial x is going to be equal to 1, and same with partial nu by partial x. Oh, yes,
right.
It's eta. It's eta. It's not.
It's eta, not squiggle. As I said before.
No. Squiggle is xi. The one on the right is eta.
Lurk, our real life issue, not a protest against breasticles. Okay, Jeff. Okay, cool. I got my partials. Yeah.
All right, and then you want to take partials of t, and so then we can say that partial x is partial xi plus partial n.
Oh, okay. Okay, one sec. So you're going to say from here, I'm going to move this over. Wait. Wait a minute. Sorry. Repeat that again?
Our partial x, so like the same way that we wrote our operators up above.
Yeah. Oh, partial x.
Partial x
yeah.
is equal to our partial xi plus partial eta.
Partial xi plus partial zeta. I mean partial nu.
Eta.
Oh, wait.
Or nu or whatever. I forget the Greek names, but
okay.
There are other variable.
Why is that? Where did wait. Okay. Oh, I see. Okay. Because you're saying like the whole derivative has to be the derivative of the transport things.
Mm-hmm.
Okay. And is there a factor of 1/2 in there, maybe? Or no?
No, I don't think so.
Okay.
Inevitably, it doesn't really matter because the whole equation becomes equal to 0. But we'll also say that partial t.
Okay. Partial
is
t
equal to is negative c partial xi plus c partial nu.
Okay. Why is this one minus and plus, and this one's plus and plus? Ooh. Partial psi. Oh, okay, wait. I think I'm starting to see it. Okay. Partial psi. No, partial. No, I don't get this. Hey, where the fuck? What? Why is this minus and plus? Is that coming from here?
Hold up, I'm thinking. Sorry, I'm reading through this in my notes from last semester.
Yeah.
So,
I think this is where the shorthand is starting to fuck me because now I'm confused like what the subscripts are for different things. What level of education are you at?
let me screenshot this and ask you if you hear real quick.
All right, you're good. Let me catch up with chat. What level of education are you at? This is probably PDEs. I think this is a pretty high level college question, but don't be discouraged that we're scared at this. We were working on something a lot more simple before this, and then we were doing some physics before that. So, but every once in a while, I like to do some high level math things to expand my brain. Matrices. Speaking of Eric, we have done a lot with matrices before. If you need help on Gaussian elimination, feel free to submit that website there has a place you can submit some screenshots for us to do questions. Okay, let me see what Zach's saying. Make a system out of x and t in terms of eta and psi. Okay, I think I agree with that. Yeah, that's what I was trying to do. I just didn't know where the fucking partial was coming out of. Okay, so if I can say x is equal to eta plus ct, and then x is also equal to nu minus ct, and then take derivatives. Okay. But then partial x is equal to partial eta plus partial ct, right? Sorry. I think I have this so far, Zach, right? So partial x is equal to partial squiggle plus c partial t. X is equal to... Okay, I like that. Yeah. You say combine these two. So then, yes. That's where I thought there was a 1/2. So x is... So 2x is equal to eta plus nu. Right? Okay, so x is equal to eta plus nu, and then this is all over 2. So then partial x would equal... I think there should be a 1/2 here. And then maybe if we want to do it in terms of t, then I'd have to say, okay, so ct is equal to x minus squiggle, eta. And then ct is also equal to nu minus x. Okay. So now if I combine these two, I get 2ct is equal to nu minus eta. So then t is equal to 1 over c, or 1 over 2c, nu minus eta. And then so partial t. No, you're good. You're good. I can't do algebra. You're okay. Oh, but let me make sure I give you a shout out, Justin. We're gonna go raid you after this, right? You are on the calendar. What are we doing, actually, Justin, on your stream? I remember seeing it. It's called Learning Lean. What's Learning Lean? Like, efficiently learning things, or are we learning about promethazine?
Are we learning about things while on promethazine?
Oh, lean is a formal proof system. Okay, we're not learning while we're on lean either.
Oh no. no.
Lean is cough syrup medicine that dumb people take because they're bored. Let me see. Kaiju says, question for anyone here, but how do you guys studying both math? How do you guys studying both math and English? I've been struggling with both, and finals are inching closer. I'm trying to figure out how to maximize my chances, and I hope to go to engineering. Best way to learn math and physics is to do math and physics. That's what I always say. So, math and physics isn't a class like AP Human Geography or whatever other garbage classes we were talking about, where you can just read things and memorize things and then you just recite them for a test and you're great. Math and physics is very much an applied class. So doing problems will help build up that muscle memory for you to do similar problems on tests, and also you'll get good at pattern recognition of saying, oh, this is this type of differential equation, I need to use this type of solution, or this is this type of physics thing, I'm going to use this conservation law. That's kind of my advice for it.
And also, whilst your English isn't too bad, I would point out the obvious.
Yeah.
Question for anyone here should then have a full stop.
Question
for anyone here, full stop. Capital full B, stop. And then the rest is probably about right. So.
Yeah. Actually, you need the chain rule for this. Oh, okay. Wait, what's going on?
Yeah, that's what was throwing me off because I was trying
Jesus Christ, what is this?
But I was like searching through.
Oh no. Okay, here. Just in the interest of time, let's maybe just put a pause on this Breasticles, just so I can. We'll pick this up next time, but this is great. I like where we're going so far, and I think we're getting great. But yeah, I'm a little short on time today. Okay, cool. We'll check this out. Cool. I'm gonna save this in, and then we'll finish the second half of this tomorrow or Wednesday. Okay, let me see.
When did that crank without a name go?
The crank without a name? Who crank without a name?
It was like, just, the fuck is that, he says, and then like, the fuck is what? He didn't
Ooh,
respond.
Yeah. Ooh, this is fun. Someone has a matrice question. More physics, more that. Milkman, what do you got for me? What's on here? Oh, phase shifts? Yeah, this is kind of cool. Okay. And then Eclipse, how difficult is yours? We'll see. The matrice question? You like matrice questions. Then it was Omar have something with masses. Okay. Oh, I hate coefficient of restitution. We don't learn that in US physics. That's strictly a British thing. Coefficient of restitution. Yeah.
I don't know that one.
Yeah, it's a UK like physics thing. They love coefficient of restitution. One of the best analogies I've heard for learning physics is that like finding the answer is like navigating a spider web where each strand is an equation. Over time, you learn how to navigate the web. Yes, and then I would say the other brilliant thing of this is if anyone's ever been to hyperphysics, this is the OG way of us learning physics. They love this whole nested map of things. So for instance, E&M is like, ooh, electric charge, and then, oh, here's electric charge, but electric charge also connects to Coulomb's law. Once you get to Coulomb's law, you can do Gauss's law, which Gauss's law gets you to electric field, and then like, you know, this is physics. It's a bunch of topics that are all kind of connected to each other, and you learn about all the webs, all the connections. Okay. All right, let me spin the wheel. I have 36 minutes-ish. I'm going to try to work as quickly as I can through all you guys'. All right, let's go choose a winner.
Let's go gambling!
Eclipse has a really big chance here. Eclipse has been waiting for a while. Yeah, it's me. All right, cool. We'll see you just on the stream. All right, let me see. Maybe I can do part of this question. I don't know if I can do all of it. This is already getting... Yeah, oh, this is mirror charges.
Oh, no.
Oh, Eclipse. You're going to hurt me. Method of mirror charges. Yeah, it's like one way to represent, I think, like electric fields and stuff. Yeah, there's always a trick. Yeah, okay. Yeah, it has to do with, grounded sheets and stuff. For something to be grounded, it has to have zero electric field and I think like zero potential on it, right? So what we do in order to represent a grounded material is we place a mirror charge of an opposite charge, which essentially negates out the effect of the positive charge to create a zero potential here. I think that's usually what we do. Okay. Yeah, exactly right. Okay. A single positive point is located at an angle pi over 6 above the x-axis between two sheets. Okay. At r prime equals r. I don't know why they put these primes on things. You were to find the electrostatic potential for points inside the wedge. Right. Carefully sketch the location of the image charges and complete the table below. How many image charges are required? Right, okay. You do not have to calculate the angles. Simply call them phi 1 and phi 2. Interesting. This is maybe early college. I don't think it's super difficult. It could be late high school. Actually, you don't do image charges in high school.
Yeah, I was gonna say, I think this is like beginning of like a upper division.
Yeah.
Of the E&M course.
But then calculate the location of the image charges and complete the table. And then we don't need the angles, but wait, how do I know how many image charges I need? Because if I need zero potential here, don't I just need another one here that's like minus Q? And it depends on the charge, right? If this one is positive, then I think I need another charge here, which is Q minus. Let's just pretend this is positive. And then that should create an equipotential here for this, which is the same thing as being grounded. The issue is that then this is not grounded.
Nice.
Am I on the right path at least, Eclipse, at first? That let's pretend that I didn't even have to worry about this part of the wedge. If I just had this wedge and I wanted this to be an equipotential, I'm pretty sure I would call this Q minus and I call this Q positive. Yeah, it's your real E&M. It's upper division E&M. I'm a mage. I don't need no math and science. I don't understand it anyways. What's up, Scoop? And then for this one, I think you just you'd have a minus charge here.
Or English. Doesn't need English either, it would appear.
It doesn't need either.
And
So
I quote, I don't need no math, so you
don't
need some.
need no.
Double
But
negatives don't work in English. Fucking cretins.
Cretins. Is that what we call them, cretins?
Cretins, plebs, lower beings, genetically devoid. I don't know, pick one. Scum.
Scum.
I might be too hard.
What's scallywags?
Scallywags. I
I
don't
like
know.
scallywags. You just have to divide 360 by the wedge angle to get the number of charges. You have to just divide 360 by the wedge angle, and then it's just all symmetry. Okay, so 6? Is that what we're gonna say? 360 divided by 60 degrees is equal to 6. So I need 6 image charges? It's kind of a mess. I know there's 2 here at least. The issue is that then these two like fuck with each other, and this is no longer an equipotential. Oh, 5 image charges and 1 real. Well, this is the real charge now. Okay. It's so funny. I don't think I ever even did image charges when I was in upper division E&M. This is something new that I've seen. I think engineers like it. It's always their fucking tricks. They love their tricks. Okay. Wait, they don't even want us to find the angles. So you literally just say that this is Q0, and then you just say this goes up to Q5, basically. And then you just say these are different angles. This is kind of silly. What?
I'd love to know what the application for this is.
It's so yeah. The application, a lot of things with double E, or anytime you have like antenna design and stuff, or you get like grounding plates. And if you wanted to figure out what the electric potential was from this configuration, a cute little trick is to pretend that these things are gone and they're not affecting it, and then they can be replaced by a configuration of other like fake charges that create the same effect. And then it's a lot easier to calculate electric potential from individual charges because you can just do sum of KQ over R. This is like the easiest way to figure out the potential of a systems of point charges. And it simplifies it a lot more than having to consider I have lines of grounded plates.
I would just beat my head against the Poisson equation until it worked out.
That's the other way. Yeah. So you can also set up. You can set up Dirichlet shit, right? You could do this, right? Is equal to whatever. Or I forget what it is, but yeah. You can set up the boundary conditions.
Because the charge is enclosed.
Right. Yes. Yeah.
But with the charge enclosed, the only difference is you would have to probably pull in some what's it called? Green's functions.
Yeah.
But beyond that, I mean, you would just beat your head
Okay.
against the Poisson equation a bit.
In the essence of time, I'm gonna post this. Eclipse, if you have the solution for this, can you just drop it in my Discord so I can look at it? I'm curious to see it. I kind of get it, and I understand the concept, and again, why we use it, but I just can't like actually do the question. But anyways, fun. All right, let's see. Yeah, let's boost through as many as I can. Let's go pick another winner.
When's my turn? Wait, which
Let's
one?
go gambling!
When it's my turn, I'll wait. It's okay. There you go. Omari. Omari's been waiting for an hour, so okay, cool. I gotta remember coefficient of restitution. Oh, it's okay. Well, whenever you get it back. I mean, it'll be on the Discord for a while. The Discord's forever. Okay.
Well, I can't even see that text.
You can't even see this text? No? No?
Sorry, the TikTok comments, I can't see them.
Oh, yeah. No. It's sometimes it bugs out and it'll post old comments new. If that makes sense to you.
But I can't see
TikTok
anything.
bugs out sometimes. You can't see any comments?
Oh. I can't see them.
Oh. It was a final, so you don't get your work back? That's whack. Okay. Particle P with a mass of 3m is moving to the right in a straight line. Particle Q is moving the opposite direction. So these two are going to collide with each other. And that has a mass 5m. The particles collide directly. Immediately before the collision, the speed of P is 2u. And the speed of Q is u. Or we're going to say minus u. Right, because it's going the opposite direction. The coefficient between P and Q is equal to E. Show that the speed of Q immediately after the collision is this. Okay, so I gotta go remember what coefficient of restitution is. There we go. Yeah, it's this ratio. Relative velocity after the collision, relative velocity before the collision. V's the final. Yeah, okay, this is what I have to remember. His is Milkman, or no, I think his is literally just called Eric.
Let's see.
Yeah, okay. Okay, there we go. All right, so E is, and then also they're saying this is the speed. Man, that's absolute value shit. Okay. Let's see. This is moving at a higher speed, and it has less mass. This is moving at a slower speed with more mass. Which one's going to win out, actually? That's a good question. You've never heard of coefficient of restitution? Yeah. It's, they use it in the UK for sure. I don't know where Omari is from, but yeah. It's kind of a whack thing, but it has to... It's the ratio of the velocities... The relative velocities afterwards versus the relative velocity before the collision. Okay. All right, so VB minus VA. Well, we don't have that, right? Show that the speed of Q immediately after the collision is that. So that would be VB. Okay, so E is equal to, let's call this like Q prime. So I'm going to say Q prime minus P prime. And then this is going to be over the difference in their velocities before, but the difference in their velocities before is equal to 2, right? Because that's 5m minus 3m. So it's equal to 2m. Cool. All right. So then, and then they're calling the coefficient of restitution is E. And then I'm solving for Q prime. So I'll say Q prime is equal to 2me minus P prime. Okay, so I just have to find the velocity afterwards. So by conservation of momentum, total momentum before, that's going to be mass times velocity. So that's going to be 2u times 3m. So that's going to be equal to 6mu. And then this is going to be minus 5mu. So that's just going to be equal to mu. And then momentum afterwards. That's going to be equal to 3mp prime. And then we don't know this next one, but this is going to be plus 5m q prime. Okay. Oh, very cool. Okay, so now I can get an expression for what p prime is. Because I know that this also has to equal this. This has to equal mu. So let's get an expression for... So first of all, I can get rid of all the m's. Let's get rid of all these m's. So 3p prime plus q prime is equal to u. So p prime is equal to u minus q prime all over 3. And now I can plug that into here. And so I'll get q is equal to... I don't like having the m in there anymore, though. Oh, wait. No. This is wrong. This wasn't m. Sorry. This was 2u minus u. That was equal to 3u. Sorry, that's what I meant to say. Sorry. This is 3ue. Got you. Okay, this is better. Okay, so now Q prime is equal to 2UE minus U over 3 plus Q prime over 3. Where are we going to get the 8 from, though? Let me think.
It's physics. You could just say it pops up.
It just pops up. It's just there.
It's just there.
Well, okay, this is actually kind of cool. If I move this over, I'm going to get that 2/3 Q prime is equal to 2UE minus U over 3. I can factor out the U and then multiply by 3/2. So Q prime is equal to U times 3/2. So that's going to be 3E minus U over minus a half. They got U over 8, 9E plus 1. Uh-oh. Oh dear. Oh dear. I don't like coefficient restitution. This seems like math and physics clothing. Yeah, because at the end of the day, you're like, wait, what? Like, what's the physics in this? I mean, the only physics we kind of used was this. Momentum before has to equal momentum afterwards. But then after that, you're completely right. I just put on my math goggles and I'm like, fuck this. Like, we'll just manually calculate it if it wants this. Here, let's just throw this at chat real quick. Let's see what chat's doing. It might have something to do with the fact of... I'm thinking because coefficient restitution is the absolute value. Yeah, see, okay, cool. So look, yeah, conservation, right? Yeah, okay, cancel the M's. Okay. Okay, so I did something wrong with math, I guess. Let me see if I had that right. 6mu minus 5mu, right? Yeah, 6mu minus 5mu. Oh, I see what I fucked up.
This guy stinks!
Wait, 6mu minus 5mu. Wait, 6mu minus 5mu, yeah, is equal to 3mv Oh, I forgot the 5 here. I just dropped the 5?
You're not that guy, pal. Trust me.
Oh, no.
You're not that guy.
Oh, I'm making mistakes. This is not good. Okay, there we go. That's where this was wrong. Uh-huh. Okay, so then there's a 5 here. That might help out. So U is equal to 3V plus 5W. What's up, Justin? W minus V is 3EU. 3EU. U is... What are they calling V and W, sorry? The velocity after the question is that. Okay. Yes. Okay, I agree with this. That's cool. Yep, and then Q minus is that's equal to E. I should be able to just plug this in. Q prime is equal to 3 UE minus oh, I see it. Minus U over 3 plus 5/3 q prime. Oh, okay, okay. I'm going to multiply everything through by 3. So I'm going to say 3q prime is equal to 9ue minus u plus 5q prime. Got it, okay. I want an 8, though. I want an 8. Yeah, because I'm solving for q prime. One sec. E is q prime minus p over 3u. Oh. Yeah, this is a plus. There we go. Plus. Minus. Plus. Minus. Move it over. Got it. 8q prime is equal to 9. Or so is equal to. Do I want to pull the e out? No. I want to say 9u. E plus 1. No. Sorry. I want to pull up this u. U, 9e plus 1. And then I divide by 8. Okay. Got it. Okay. Q prime is equal to u over 8. 9e plus 1. Nice. Oh. That took way longer than it should have. Okay.
You didn't use my magic trick.
The algebra obviously lends the solution. Answer is this. Yeah. Find the range of values for E for which the direction of the motion of P is not changed. Yeah, this is the weird thing here, right? Because you have absolute values on these, and these are velocities. So if they switch directions, that's gonna mess some shit up. If one's negative, one's positive. Let's see. Curious. I'll learn with chat. This is Edexcel IAL, I think. UK Edexcel A-level further maths. Yeah. Let the coefficient of restitution be this. So, okay. This is just so annoying. You're just plugging shit back in over and over again. For P's direction not to change, P must still move in the positive direction, so V must be greater than or equal to 0. And since U is greater than, because that's the initial velocity, sure. Okay. Right, and coefficient of restitution does have to be less than 1. Okay. Fascinating. You study this age 16 and 18? Wow. That's pretty advanced. We just don't deal with coefficient of restitution. It is not an American physics thing. I understand why you use it. It's for collisions, it's cool to talk about the ratio of the, it's kind of like it's the relative velocities. So it's kind of, is it the velocity of the center of mass almost? Is that a way to think about it? No, I just lost all my lights. There we go, now they're back. Okay. I don't do this module though since I chose to focus on statistics instead of mechanics. Yeah. Yeah. Okay. Just in your interest of time, I'll call this one done. But yeah, you can go solve the rest of things. Kind of an annoying question. It's a that question is it's what do we say? Math in physics clothing. It looks like it's physics, but it's really just a bunch of math. Okay, good to see you, Eclipse, though. Thanks for coming by.
Pretty sure my t-shirt breaks copyright.
What is it? Let me see. Oh, I love that. Can't someone else do it? Can't someone else just do it? Reminds me of, yeah. That's from, that's Dragon Ball, right?
Yeah.
Alright, let's see. Questions. Who choose winner? Choose winner, please. There you go.
Let's go gambling!
Why have Tilda as a name?
Jay! Wow. 107 minutes ago. No upvotes though. Why can't I click on his question though? Excuse me? Oh, it's because it's a really small emoji.
Yeah, I was gonna say it seems like a skill issue because I clicked it first time.
Skill issue. This is probably another kind of annoying just physics thing of just plug and chug through stuff. Block A with mass is suspended from a vertical string as shown below. Dude, why is the pulley here? What's up, Bella?
Yeah.
It was vibe coded. Hey. Zach isn't wrong.
Actually, you know that timer there.
Yeah.
You can tell that that's vibe coded.
Well, the reason also why the timer's wrong between the two different things because my system clock on this Windows PC just drifts for some reason. It makes no sense why it does it.
But no, that's not being derived from your system clock.
It is. Watch, because now I'll fix it. And then now they should be the same.
How?
Actually, now they're not. Yeah, wait, you're right. They are different. I don't know. Whatever. It's close. I don't know why the
only reason I know that is because I was asked to test how efficient or effective vibe coding is, and it's just horseshit.
No, look.
That was one of the tests.
Now they're synced. Do you see? Now they're synced. Actually, now they're very close.
No, but it's not synced to your time. It's synced to a server somewhere else.
No. But I think it is synced to my system clock. It's weird because do you notice how now the times are like closer? It's JavaScript, yes. Yeah.
Yeah, so it can have access to your system time.
I think it does somehow though, dude, man. I think it does.
If you could access a person's system using JavaScript, then everybody's computer would be at risk.
I don't know what it is, man, dude. For some reason it does read my local time though.
Well, I really hope not, because I'm pretty sure you can break the world with that particular exploit.
Well, because watch here, I could manually set my time here. Here, can I change my time? Here, I'm gonna change my time. We're gonna change my time to like 7 minutes forward, and watch, it'll fuck it.
It might not reset it.
Yeah. See, now it says there is no event. Do you see how now it says 1 minute? Yeah. And here, now I'm gonna tell it to go sync. I'm gonna tell it to go sync the time back, and it'll change. I don't know. I'll send you the code if you want to take a look at it, but I think it is reading it from my system clock somehow.
Well, that was the other thing as well. It was just esoteric nonsense that ChatGPT was spitting out, and it was like no human beings writing it like this.
Yeah,
and if
I think
no
Jeff
human
is right.
Write it like that. You can't.
It gets
read
it through your browser.
You can't read it.
I think when your browser does stuff, Sensation, it sends what your system time is.
Oh yeah, that could work.
I think that's what's happening. Yeah.
In the container, yeah.
Yeah, it'll fix itself. It's because the system, and I don't know why my computer doesn't know how to like keep fucking time. My Casio here knows how to like keep time.
Because I keep using Windows.
Yeah, that's true. Well.
Oh yeah, fun fact. Well, I think I told you this. All of France switched over to Linux.
Oh, good for them. Good for the French.
The French government went, no, Windows is shit. Everyone turn on Windows.
Okay, I'm gonna skip this one just because I don't have time to do this. I know how to do this one. It's annoying. We got to figure out normal forces and whatever, and then tension. Yeah. Let me help someone out that I know I can help in the next 5 minutes. Maybe Milkman. Let me see if I can help out Milkman. Yeah. Just use Lagrangian mechanics. God no, dude. I don't need to do that. Oh, and I got rid of my browser. Sorry, 1 sec. Today's a little bit of a struggle. There we go. Okay.
You could just assume that the string snaps and the block stays still.
Just say it's over, dude.
No acceleration, yeah.
All right, the graph represents
no tension in the string.
a sine function where a is greater than 0, and where there is a minimum possible positive phase shift. Okay. Find all the parameters. Oh, wow. That's kind of a mess. But okay. I got a notification from mathematics says you opened Instagram again at 4:40. Yeah, that's fake. That's rage bait right there. Okay. Okay. So the bottom is at -4. And then the top is at +2. So that means the midline is at negative. What is that? -4 plus 2 is -2 divided at -1. Oh, which they already kind of showed there.
Oh, yeah.
I should have been able to get that. Okay, cool. Okay. So this tells you a couple things just right off the rip. This tells you right away that D is equal to -1. Good. It also tells you that A is equal to 3. And, well, now here's the key thing. We want the minimum possible positive phase shift. So I think we want to make this equal to -3. Oh, no, it says A is always greater than 0. Never mind. Okay, take that back. Okay, so there's A, there's D.
A should be negative, right?
Well, no, it says A has to be greater than 0. So that means we have to phase shift. Yeah.
Yeah, you're right.
It's annoying. So this is the phase shift. The phase shift is going to be what's that going to be? It's between pi/3 and 2pi/3. So it's between 2pi/6 and 4pi/6. Oh, so it's pi/2. Right?
I think so.
I think so.
I think you could also just say you could say it's pi/2 just off the fact that sign would go negative.
Mm-hmm.
By the period.
Yeah. So that's how you get that. So you just look at, so wherever sine curves usually start at 0, go up and then come down. And so you just want to figure out how far away that is. And so yeah, in that case it's just pi/2. And then this is always like 2 pi over the period, right? Is what B is. So the period in this case is equal to, man, I hate how they labeled this. Okay, so this is pi/2. Or here, let's just see. The period is just 2 pi. Right? Or no, the period is pi. Yeah. Yeah. Period's equal to pi. Not yet. Wait, sorry, not quite yet. I don't have this right, actually. Sorry. Yeah, wait, isn't it? Am I right?
Yeah, you're right.
I am right.
It's going to make a full oscillation from positive, negative back to 0 in a
yeah, okay.
frame of pi.
All right, so B is equal to just 2. And there we did it. ABCD. Okay. Cool. Nice. Good question there. Milkman. Oh, I forgot to tell you.
Well done.
Milkman was number 2. Okay. Let me see which other ones we had. Blue had this. You do yours real quick, Blue. And then I'll get the last one. Okay. Analyze the given points A, B, and C. Suppose you want to plot point D such that ABCD is a square. How does knowing that a square has 2 pairs of parallel sides help determine the unknown location? Oh, okay. Well, I know I can just like take this and just add it to this one, and then that'll be it, right? Yeah. Right? Well, I think we have to assume that AB equals BC, right? Yeah. Okay. Well, I can say that, you were thinking slope intercept? Yeah, I was thinking, yeah, these are just vectors, right? So, I know that, it could be a trick question. I wonder if we're allowed to use dot product stuff. I would also just say that AB dot BC has to be equal to 0. But I wonder how much we're allowed to do that. Help. How does knowing that a square has 2 pairs of parallel lines help to determine the unknown location? The line from the line from A to D must also, I don't know what. This hurts my brain.
I feel like it hurts because it's obvious.
Yeah, it's obvious. Yeah, it's like, why is 2 plus 2 equal to 4? And I'm just like, I don't know. Ask Terrence Howard, dude. Go ask him. The line from A to D must be the same. Magnitude, and also I just don't know like what level of math you're allowed to answer this with. To be a square. How does knowing that a square has 4 right angles help determine the unknown location? Okay, you can just say that.
I mean, that's the same as saying that there's 2 pairs of parallel sides, I guess. Or it's
80 is perpendicular to BC, maybe? Yeah, right.
Yeah, the 2 pairs of parallel sides have to be orthogonal to each other.
Yeah.
I guess. I feel like that's obvious. That's just...
Oh, the slopes multiply to 1. So yeah, so okay, if we're thinking like, I have to think like how like, what level of math we're allowed to talk about. They probably don't deal with vectors. They probably are just dealing with slope-intercept forms of things. So yes, okay. I think this is what they wanted to say. We could say that AD and BC have the same slope. Right?
Yeah, true.
I think that's probably what they want to say.
I guess you could just look at like B to A and just look at how much it goes up and how much it goes to the side and do the same thing. But
and then this is AD, slope of AD times slope of DC is equal to 1. Wait, is it equal to 1 though, Jeff? It's equal to -1, I think. Yeah, -1.
My name is Jeff.
Yeah, very good. Okay. Determine the point D. Oh, that is what you said? All right, my bad. Okay. So, like, I would literally just take this. And then with the beauty of technology, we can just do this. And be like, cool. It's equal to 5, 3. It is point D. And then you'd have it, yeah.
What was the point of that? Like,
I don't know, dude.
what
it's
is like? What does that question accomplish? Or,
it gives the teacher something to do, I guess. I don't know. I would have wanted to teach this in terms of vectors, right? I would have wanted to be like, hey, you know, this is a vector BC, right? And if I add that to vector, which is literally what I did, if I add that to vector BA, I get my other point. I could have also added AB to BC. That would have been another way to do it. I think that's the way to, like, teach this. Or maybe it's for a systems of equations. Frescals, maybe?
maybe, but even then, it's not even really like a equation. It's just like arrays. There's like there's not an equation necessarily, at least not an obvious one.
Or no, you could do.
Like,
Right, couldn't you find the equation of the line perpendicular to here at this point? Find the equation of the line perpendicular to this point, and then just set with those two intersect? I think it's another way to do it.
yeah.
That's
And they want you to work together on it, I guess, as a
work together. Yeah, what's this? Not your homework problem, our homework problem. Communist math. What is this? Okay, Ejo, last one. And then I really gotta run. Okay. For each of the following matrices, state whether or not is in the desired final form. What's my final form? If it is, find the solution to the system of equations which it represents. If not, do the required steps to put it in the final form, and then find the solution. You may use your calculator, but you must show what you did step by step. Okay. So I think what they're doing here, this is what's called a augmented matrix. Yeah, augmented, and it's supposed to be it's a 3x3. So you have 3 equations and 3 unknowns. So you want to turn this into something that looks like this: 1 0 0 0 1 0 0 0 1, and then this will be the augment, and then this will be like ABC. So it's not in its final form yet. It's close. It's very close. Usually how you do these is you do like the snake method, I say, which is you go this way. You make sure this is 1 0 0, and then you make sure this is 0 1 0. So this is already 3.
I believe, if I remember correctly, I don't think you even necessarily need to worry about the upper right.
The order?
No, the top right triangle, I don't think you need to worry about, because you can do a back substitution, going from your bottom row up, substituting back in to solve the system without actually having to worry about the upper right triangle.
Really? So wait, you only deal with this?
Yeah, I believe so. I think there's like some special cases where it might not work, but in most cases you can just do that and then do a back substitution. That's what we've in essence done, is solve the bottom equation for just Z.
I got you, and then you just plug it in.
Substitute Z back in, and then substitute Y in.
Yeah. So the other way to do this is, in order to make this a 0, we have to do negative. You'd say negative 3 R2 plus R3 gives you R3. So then that would leave you with 1 0 0 21, 0 1 negative 2 negative 2, and then negative 3s of these would be 0 0. Negative 3s of these would be 6. 6 plus 5 is 11. And negative 3s of these is 6 plus 8, which is 14. Right. Yeah. And then once you have this, you would do R3 divided by 11 plus R2 gets you R2. So then, and I actually, I would I would do R3 divided by 11 equals R3 first. So now that you have 1, 0, 0, 21, 0, 1, negative 2, negative 2, and this is 0, 0, 1, 14 over 11, and then the final, yeah, it's the back substitution. Now what you do is you say R3, 2R3, sorry, plus R2 gets you R2. And that would give you the final thing, which is 1, 0, 0, 21, 1, 0, sorry, 0, 1, 0. R2-D2. It is May the 4th. It is Star Wars today. Star Wars Day or something. And then this is kind of ugly, though. What? Because this is negative 22 over 11.
Yeah, and see, that's when the back substitution is, like, convenient.
Yeah.
Because we know what our third variable is, and we just substitute it in. Then we have our second variable, and then you throw your
your whatever, like, fuck
second variable and your third into your first one, and then you get everything without doing a bunch
I see. Yeah, you just... The teachers want it in this form just because it's very easy to read, but I totally understand. You're doing the same thing when you just back substitute anyways.
Yeah, well, and that was, like, when I took linear algebra, that was one of the methods that they taught. So, right, they first taught this, and then we're like, all right, well,
yeah,
now we can do a back substitution. And we actually had, like, questions on the test that were like, hey, like, solve this using a back substitution.
Well, there you go. That's solved. So, good job, Ejo. All that makes sense. Okay, that's it. Let's go close out the stream. All right, thank you again, everyone, for coming to Actual Education Office Hours today. Appreciate all the questions. Appreciate y'all's patience. I was on a little bit of a struggle streak today. But we'll be moving and grooving once the week starts more. Wait, today is Monday, though, right? Right? Uh-oh. I thought it was Sunday. W stream. Thank you, guys. Yeah, I appreciate it. We don't have a stream tomorrow, per se, with the normal homework stuff. I'm doing an AP Physics review stream for all the students. But feel free, come on by if you want to get help with AP Physics 1. Or if you just want to learn AP Physics 1 with us, we'll be doing that. And then I will announce we'll have a stream on Wednesday to make up for no stream on Tuesday. And other than that, stay tuned in the Discord. I have some announcements for some more updates to the giveaways and things we had. We'll be selecting those this week. And then I got to decide what game we're going to do for Friday. We'll see. I'll come up with it. But okay. Let's go raid someone. So again, make sure to always check out our website, actualofficehours.com. That's where you can figure out the streaming schedule for when we stream. Also the questions that get put in there. Sneakers, you just submitted. I was like, wait, I just cleared the queue. You just submitted this 0 months ago. Yeah, I also can't really do op amps. That's an EE thing I haven't done yet. And it's just memorizing a bunch of equations. It's annoying. Okay, let's go raid. Let's go say hi to Justin. Justin is doing a proof-based math program called Lean. So we're gonna go say hi to Justin. There it is. So, check him out. Oh, this is fun. I love this. Actually, this is really cool. I've seen this before. Hypatia showed this to me, actually, way back in the day. So, go check it out. We'll see you tomorrow for physics. Otherwise, we'll see you on Wednesday. Peace.
Here, go. Okay, let me try that. So what if I say have I wonder if it's too ambitious to try to say X is in C immediately.